Hello YouTube, this is Dazza the cameraman. Today is Saturday morning, February 23rd, 2019. It's just gone 10:10 AM New Zealand time, and this is another attempt to try and answer the questions by Steve Matthews, Teeth of the Lamb. So Steve has posted this reply under my video response to his challenge. He says, one minor technicality that you show the moon rising in the west for the man standing on the dark side of the earth at the time stamp 14 minutes 45 seconds. It's because, as I mentioned in my presentation, the east and west are reversed, so the man on the dark side has his east and west reversed. The old saying where east and west meet. As the moon or sun set in the west for one man, it is simultaneously rising in the east for the man on the opposite side of the earth. Hope that makes sense. And Steve very kindly says, and your graphics are absolutely stunning, great job. Now, I posted a detailed reply to that comment, and you can see that Astronomy Live has also posted a reply on that. You can pause the video if you'd like to read that, and I may do another video looking at the diagram that Astronomy Live has posted. And again, you can pause the video here if you want to read my reply to Steve Matthews. But what I'm going to do is try and give a visual answer to this, because obviously that's always easier than just words. So again, we're going to use Starry Night, and I will try and explain what's going on to Steve Matthews. So again, we're looking at the view in Starry Night, set Phoenix, Arizona, United States, January 20th, 2019, 6 p.m. And I've got this in Alt Azimuth mode at the moment. I'm going to change it to equatorial. You can see these two circles which represent the penumbra and the umbra, the outer shadow and the inner shadow of the Earth, which the moon is about to pass through. Now, it's important to note, of course, that the moon is rising in the east, or the east-northeast here, and as I run this forward, we will see that the moon is crossing over from the easterly direction to the westerly direction, which is what we see every night, of course, with the stars and the moon, and also the sun during the day crossing the sky from east to west. And this rotation is in fact caused, or this motion rather, is in fact caused by the rotation of the Earth, which causes this apparent motion across the sky. So here we go, the moon is about to set in the west-northwest. So let's take that back to where we started. And this time I'm going to change the view to equatorial. And I've got Starry Night locked onto the background stars instead of to the moon. So let me just play a bit of that again so we can just set the scene. Again, you've got the moon moving from the east across the sky to the west. Now you'll notice that in equatorial mount that there is no rotation. Orion over on the lower right there is showing no rotation whatsoever, because the equatorial mount cancels out the apparent field rotation as we follow across the sky. So once again, even in equatorial, we see the moon moving across the sky from east to west. So let's bring this back again, and this time I'm going to zoom in, and hopefully all will become apparent. So once again, keep an eye on these two circles. The outer circle is the edge of the penumbral shadow. The inner circle is the edge of the darker central umbral shadow of the Earth. So let's run this forward again. And hello, we're tracking the stars across the sky, but now the moon appears to be moving from west to east instead of east to west as it was before. In which direction is the Earth shadow moving? It is moving from east to west against the background stars. So as I tried to explain in my detailed text reply to Steve Matthews, the rotation of the Earth is faster than the apparent orbital motion of the moon as it orbits the Earth. The moon takes approximately 1 month to orbit the Earth, which is where we get the word month. It means month, because it takes about 1 month for the moon to orbit the Earth once, but it takes the Earth 24 hours to make one rotation with reference to the Sun. So the rotation of the Earth is at 15 degrees per hour, but the rotation of the moon across the sky from west to east, because it is actually orbiting the Earth from west to east, is actually overtaken by the rotational motion of the Earth at 15 degrees per hour. So it's only when we look at the background stars that we actually see this west to east motion. Let me bring that back again and we'll look at that again. Okay, so even though we're tracking the stars across the sky, the moon is actually moving in the opposite direction. Now let's finish by looking at the diagram that Astronomy Live had posted in his reply to Steve Matthews. This is a video by Astronomy Live, right and wrong way to illustrate eclipse shadow. So I'll play this and I'll read Astronomy Live's explanation of what we're seeing here. Now I've gone full screen on this so that we can see the objects more clearly. Because of the scale and size, it is difficult to see the objects when we draw them to scale. So Astronomy Live's explanation as I play the video is that in this diagram the left panel is a 2-scale diagram of the moon moving in an orbit around the Earth. The red dot represents a stationary observer on the rotating Earth. The green dot represents the moon moving in its orbit, and the yellow line represents the moon's shadow projected into space in a direction directly opposite a distant sun far off to the right. This shadow sweeps over the Earth and overtakes the red dot, indicating a west to east shadow direction on the Earth's surface. On the right side simulation is identical, except that the yellow line is connected the center of the Earth to the green dot of the moon. This represents a line of sight between the center of Earth and the moon. A person in line with this would see the moon at the meridian. The red dot overtakes this yellow line, indicating that the moon is moving east to west in the observer's sky. So I guess it all comes down to perspective and all of those different motions that I explained in my reply. You've got the rotation of the Earth. You've got the moon orbiting the Earth from west to east, even though it appears to cross our sky from east to west. You've got field rotation at play as we follow the moon across the sky. And you've also got the observer's latitude and viewing angle to take into account. All of these things affect our perception or perspective of what we're seeing. I hope this helps to answer your questions, Steve Matthews. Thank you for watching.